Okay, we're going to look at finding the derivative of a constant with a variable power. So if you have y equals some number, which we're using a to represent, raised up to some function, here is our derivative. The first part says we're going to get the same part back. Then we're going to multiply by the natural log of the base. And then this f prime of x is really showing that we're going to chain along the derivative of the power, which is f of x. Looks really complicated, but when we do a few examples, you'll see that it's really not too bad. So we're looking to differentiate the following here. So the first one is 2 to the x. So the first part of our formula says we get the same thing back. So it's just going to be 2 to the x times, it's going to be the natural log of our base, which is 2, times the derivative of our power. In other words, what we're really doing is chaining along the derivative of this power, which is really 1. So there is nothing to do to clean this up other than to just ignore that 1. Our final answer is going to be 2 to the x times the natural log of 2. Sometimes you'll see it written as the natural log of 2 times 2 to the x. Either way, maybe we'll put parentheses around this. Okay. Either way, there really isn't much of anything you could do to simplify this. Alright, our next example, example 2. Always start off by getting the same thing back, and notice how we have 3, which is a constant raised up to a variable power. So that's when we have this special rule. When we were talking about the power rule earlier in the course, that's when we have x raised up to a power. Alright, so if you have x raised up to a power of 3, the derivative there was 3x squared. Okay, if you have 3 raised up to the x, that's totally different. That's this situation that we're talking about where you have a variable power. Okay, so we're not using our power rule with these examples. So back to this, we would have 3 raised to the x squared. Okay, so you get the same thing back, times the natural log of our base, so that would be the natural log of 3. And then we're going to have to chain along the derivative of our power. The power is x squared, so its derivative is 2x. Once again, there really isn't anything we can do to clean that up, other than just to rearrange the order of your terms. Example 3, you've seen this before. E, of course, is a number. It's about 2.718. So if we were to actually follow this formula, because it really is a constant to a variable power, we get the same thing back, times the natural log of e, and then we're chaining along the derivative of x, which is 1. Well, the natural log of e is just 1. So this simplifies to e to the x. So this is the most popular constant to a variable power function that we see. So I like to say E for easy. E for easy, because you just get the same thing back. Okay? Gets a little bit more complicated when you have something more than just a plain x for your power. You're going to get the same thing back, but our chain rule says we're going to have to chain along the derivative of that 5x, which is 5. And again, there really is a natural log of e in between there, but we don't bother to write it anymore because it's just going to give us 1. So when we express our final answer, we're going to throw that 5 in front and then times e to the 5x. Okay? So if you skip ahead to all of our examples here, if you glance at them, notice that they all have an e in it. I mentioned that is the most popular type of function where you have a constant raised up to a variable power. Okay? So that's what we're going to focus on. On your unit test, sure, you can expect one multiple choice where it's something other than e. You might have something like 2 raised up to the 4x squared. Okay? But the majority of the problems, if I give you multiple problems on this topic, will have an e in it. So number 5 here, you get the same thing back. That 16 just comes along for the ride. And you have e raised to the minus 2x squared plus 5. We have to chain along the derivative of our power, which is going to give us a negative 4x. So If you want, you could multiply these two together, the 16 and the negative 4, to get negative 64x e to the negative 2x squared plus 5. If it's multiple choice, that's what you're likely to see for the answer. Number 6, you have some prep work to do here. So first of all, this is e to the x, and we have the cube root of it. So that's the same as e to the x to the 1/3 power, which is really the same as e to the 1/3 times x. When you have a power to a power like that, recall you're just going to multiply. So that's still equal to y, so now we're ready for our derivative. So we're going to get the same thing back, e raised to the 1/3 x, and we're going to chain along a 1/3. So that's going to become just 1/3 e to the 1/3 x. Next example, we're going to need our chain rule here because we have a quantity raised up to a power. We have an inner and an outer function. So this is where we're going to find the derivative of the outer function. So to do that, I'm going to multiply this 3 down in front. I'm going to carry along the inside, and my new power is 2. And now I have to chain along the derivative of this inside. Well, if I find the derivative of e to the x, we know that's just e to the x, and then plus 2 for the second term. Okay? There really isn't much you could do. You could take that 3 in front, and you could multiply it to the e to the x and the plus 2 term, but we'll just leave it right there, okay, for now. Last one on this page, notice we have a product of two functions, x and then e to the 3x. So we need our product rule, okay? So derivative of the first would be 1. Keep the second one the same. Plus, now reverse it. Keep the x the same. And now I'm going to multiply by the derivative of the second. So that would be e to the 3x times 3. Let's clean this up a little bit. E to the 3x plus 3x, I'm multiplying these two together, times e to the 3x. Now suppose this is multiple choice and you don't see that as an answer. Notice there is a GCF of e to the 3x that you can pull out. If you pull out an e to the 3x, you're left with 1 plus 3x. So in all likelihood, that would be your answer choice. So always be on the lookout for algebra that you could do to make your answer into a different form. Let's go on to the last page. Okay, so we have just one more example here. Notice this is a quotient. So we need the quotient rule. So low, d high, so the derivative of this, so there's my low d high, minus high d low, all over low squared. And we can clean this up a little bit. First term, we'll have 4x e to the 4x minus another e to the 4x, all over x squared. And once again, usually if it's multiple choice, AP likes to factor out a GCF when possible. So e to the 4x can come out of the top. You'd be left with 4x minus 1 all over x squared. And that's all we can do with it. Okay? Thank you. Have a nice day.